NASA scientists on Earth have recreated the creepy black spiders that litter the surface of Mars. The breakthrough left the researchers shrieking with joy and could help uncover further secrets about the mysterious structures. Spiders on Mars is the name given to a geological feature, known as arachniform terrain, that is visible in multiple locations on the red planet. In these places, hundreds of dark crack-like structures appear on the planet's surface, each with potentially hundreds of individual lines or legs. When viewed from above, these tightly grouped deformations, which can be more than 3,300 feet, 1,000 meters wide, look like a horde of spiders scurrying across the Martian landscape. Mars orbiters first spotted the spiders in 2003, and the features have continually popped up in satellite images ever since. At first, these stationary arachnids were a complete mystery, but scientists eventually determined that the spiders form when carbon dioxide, CO2, ice on the planet's surface suddenly sublimates, or turns into gas without first melting into liquid. In a new study, published September 11 in the Planetary Science Journal, researchers mimicked this process on a smaller scale using a specialized laboratory chamber to create a near-perfect miniature version of the spiders. For the study's lead author Lauren McKeown, a planetary geomorphologist at NASA's Jet Propulsion Laboratory, JPL, in California, who has been working on recreating these spiders for 5 years, the moment of finally birthing the Martian critters was almost too much to handle. It was late on a Friday evening, when the experiment succeeded and the lab manager burst in after hearing me shrieking, McKeown said in a statement. She thought there had been an accident. In 2021, McKeown led a study that first explained how the spiders form, via a pathway known as the Kiefer model. This model showed that, during Martian spring, sunlight shines through slabs of CO2 ice on the surface, heating the ground below. This, in turn, causes some of the ice to sublimate into gas, creating a pressure buildup within the ice slabs. When the pressure gets too high, the ice cracks, which enables the gas to escape. As the gas seeps out of the ice, it takes a stream of dark dust and sand from the surface, leaving behind spider-like scars that appear when the ice fully melts during Mars summer. In the new study, the researchers put the Kiefer model to the test by recreating these steps in a wine barrel-sized chamber at JPL, known as the Dirty Under Vacuum Simulation Testbed for Icy Environments, DUSTY, which recreated Mars' extremely low pressure and temperature, minus 301 degrees Fahrenheit, minus 185 degrees Celsius. The team placed a simulated Martian soil into the chamber and covered it with CO2 ice. They then heated the mixture with a lamp placed beneath the simulated soil to replicate the warming effect of the sun. It took many tries before McKeown found just the right conditions for the ice to become thick and translucent enough for the experiments to work, NASA representatives wrote in the statement. But finally, the ice cracked open and gas seeped out of the hole for around 10 minutes before the frozen CO2 eventually disappeared and left behind one of the iconic spiders. The new study also reveals a hidden step in the Kiefer model. Ice also formed within the ground, which caused it to crack open along with the ice. This could explain why the spider's legs have such a zigzag shape, the researchers wrote. It's one of those details that show that nature is a little messier than the textbook image, study co-author Serena Diniega, a planetary scientist at JPL, said in the statement. The researchers plan to perform similar experiments in order to solve the biggest remaining mysteries about the Martian spiders, including why they form in some places on Mars but not others and why they don't seem to be growing in number every year.